The proximal humerus internal locking system, or PHILOS. The proximal portion of the plate has 9 holes. The most proximal holes at level A are parallel to one another and angle the screws slightly upwards. At the next level, B, the holes are staggered and the screws converge in the head of the humerus. At level C, the holes are inclined upwards and the screws diverge in the head of the humerus. The next hole at level D is an LCP combination hole which is inclined slightly upwards. This inclination, as well as the anatomical shape of the plate, makes the screw ascend into the head of the humerus. At level E, the holes diverge slightly and incline upwards to provide the screws with purchase in the opposite calcar region. A variety of screw combinations in the proximal part of the plate is possible. The most proximal hole in the shaft portion of the plate allows either conventional 3.5 mm screws or locking head screws to be inserted. By using a conventional 3.5 mm screw in the longer portion of the hole, vertical alignment of the plate is possible. Further distal holes are of the LCP combination type. For the fixation of the tendons of the supraspinatus, the infraspinatus, and the subscapularis to the plate by means of sutures, there are 10 2 mm suture holes. There are 2 types of screws: compression screws and locking head screws. The standard compression screw can have a full thread or a partial thread. A screw with a partial thread is called a shaft screw. The 3.5 mm screw has a head diameter of 6 mm. In the fully threaded version, the diameter of the thread is 3.5 mm and the core 2.5 mm, while in the shaft screw, the diameter of the shaft and the thread is 3.5 mm and the core 2.5 mm. A self-tapping version of the 3.5 mm compression screw with full thread is also available. It can be recognized by its 3 tapping flutes. In this exercise, a self-tapping 3.5 mm compression screw will be used. Locking head screws have conical threaded heads. The self-tapping locking head screw has tapping flutes and a rounded tip. Self-drilling, self-tapping locking head screws are characterized by a pointed drill tip and tapping flutes. The self-drilling version is used mainly as a monocortical screw in the diaphysial region. The unique combination holes shown here in a 3.5 LCP allow this plate to be used as a standard compression plate, as a locked internal fixator, or as a system combining both fixation concepts. The combination hole accommodates compression screws. They should be placed only in the unthreaded portion of the combination hole, the so-called dynamic compression unit. Wide angulation of the compression screw is possible. Compression screws can be used to fix the plate onto the bone, or to achieve dynamic compression of the fracture when eccentrically inserted and tightened. The threadless part of the combination hole always faces towards the end of the plate. The space between the 2 inner combination holes, whose conical thread portion face each other, is the center of the plate. Due to this asymmetry, dynamic compression can be performed from both ends of the plate. The locking head screws are used only in combination with plates. The locking head screw must be inserted only in the conical, threaded part of the combination hole. The head of the screw will lock itself in the plate, providing angular as well as axial stability. No compression between the plate and the bone is required to achieve fracture fixation. The locking head screws have to be inserted centrally and orthogonally in the threaded portion of the LCP. Otherwise, the screw is inadequately locked in the plate and stability is not guaranteed. Even with an incorrect angle of only 5 degrees, the locking head screws could no longer be counted on to hold reliably. The beach chair position is suitable for the reduction of proximal humerus fractures. The affected arm is freely mobile, washed, and draped. The appropriate surgical approach is anterior access in the deltoid pectoral sulcus. The use of the Philos plate on a 1-1-A3 subcapital upper arm fracture, according to the AO classification, is shown. The Philos aiming device is attached to the plate with a hexagonal screwdriver. If sutures are to be used, it's recommended to pass them through the suture holes before attaching the aiming device. For the distal fixation with self-tapping 3.5 mm compression screws, the 2.5 mm drill bit, the 3.5 universal drill guide, the depth gauge, and the hexagonal screwdriver are needed. For the proximal fixation with 3.5 mm locking head screws, the centering sleeve for the Philos aiming device, the drill sleeve, the centering sleeve for K-wires, the 2.8 mm LCP drill bit with length markings and the hexagonal screwdriver shaft with the 1.5 Newton-meter torque limiting attachment are needed. The torque limiting attachment ensures optimal tightening torque of the head of the screw in the threaded hole of the plate. The anatomical shape of the plate allows an indirect reduction of the fracture. For this, the plate is placed towards the head of the humerus. The plate is positioned 5 to 10 mm dorsal to the posterior delimitation of the intertubercular sulcus, and usually 8 mm caudal to the upper edge of the greater tubercle. The correct position is found by placing a K-wire through the proximal guide hole of the aiming device. The K-wire should be aimed at the level of the joint surface. Through the dynamic part of the long hole, both cortices are drilled using the universal drill guide in the neutral position and the 2.5 mm drill bit. The length for the 3.5 mm Cortex screw is determined with the depth gauge. If a non-self-tapping screw is to be used, a thread has to be tapped. By tightening the screw, the humeral shaft, which has been displaced medially, is drawn onto the plate until the reduction is completed. In some cases, a sharp hook is needed to achieve a complete reduction. The vertical position of the plate is adjusted before the screw is fully tightened. In this exercise, locking head screws at levels A, B, and D will be used. The K-wire can be removed. To ensure correct axial positioning of the screws in the proximal portion of the plate, the centering sleeve and the drill sleeve must be used. The 2.8 mm LCP drill bit with length markings is used to drill the hole. If this drill bit is not available, or if there is any uncertainty about the depth of the drilling, it's recommended to use the depth gauge. The length markings on the drill bit indicate the length of the screw to be used. The drill bit and the drill sleeve are removed. A self-tapping 3.5 mm locking head screw is now inserted. When using the air drive, it is essential to use the torque limiting attachment with screwdriver shaft. The centering sleeve is removed. As an alternative way of measuring the screw length, the centering sleeve for K-wires and a 1.6 mm, 150 mm long K-wire could be used in addition. The tip of the K-wire should be located in subchondral bone. The length of the screw now is determined by sliding the direct Philos measuring device over the K-wire. The direct measuring device, the K-wire, and the centering sleeve for K-wires can be removed. The hole is drilled to the correct depth with the 2.8 mm LCP drill bit. After removing the drill sleeve, the appropriate 3.5 mm locking head screw is inserted. After all the required holes are filled, the proximal fixation of the plate is completed. For the remaining shaft holes, the universal drill guide is used either in a neutral or in a compression position. For increased stability in osteoporotic bone, screws might have to be placed at different angles to the shaft. Both cortices are drilled with the 2.5 mm drill bit. The length is determined with the depth gauge, and a 3.5 mm self-tapping Cortex screw is inserted. The process is repeated distally. The Philos aiming device is removed. The fixation of the plate is now complete. X-rays taken directly after the operation show the clinical result. On a multifragmentary proximal humerus fracture, it's now shown how the tubercles can be fixed to the plate with holding sutures to secure the reduction and to neutralize the muscular traction of the rotator cuff. The black rubber represents the insertion of the infraspinatus, the supraspinatus, and the subscapularis. Sutures have been attached to the tendinous insertions of these muscles. The fracture lines in this four-fragment fracture separate the tuberculum minor, the tuberculum major, and the head fragment from the humeral shaft. The fracture is reduced with the help of a bone spreader and a periosteal elevator. A pull on the sutures attached to the muscle tendon and the sharp hook may help to achieve the required reduction. The reduction is held in position temporarily with K-wires. These wires have to be placed so that they do not hinder the later positioning of the plate. The sutures are passed through the suture holes of the plate. After attaching the Philos aiming device, the plate is slid down to the bone. The plate is now fixed to the bone. The temporary K-wires as well as the aiming device can be removed. To neutralize the muscular traction of the rotor cuff, the sutures are secured to the plate. The fixation of the multifragment fracture is now complete. X-rays taken directly after the operation show the clinical outcome. When the implants are being removed, certain screws may be anchored in the plate so firmly that they cannot be extracted with the conventional screwdriver. To take such screws out when the hexagonal head is damaged, two instruments are available: the 2.5 mm conical extraction screw with left-hand thread and a 2.5 mm drill bit for metal. The conical extraction screw must be screwed into the damaged hexagonal head of the screw anti-clockwise. This can be done with the air drive at slow speed or by hand using an attached T-handle. In rare cases, this procedure is not sufficient. This screw can be removed by this method. In the case of screws that are difficult to remove, the hexagonal socket is further deepened with the 2.5 millimeter drill bit for metal until the conical extraction screw is finally wedged in firmly and the locking head screw is removed. In this way, it should be possible to remove all the screws from the plate.